Alright, today we're going to be looking at Chapter 7, Section 1, which is going to be looking at chemical reactions. So we need to be able to know what a chemical reaction is. So a chemical reaction occur when substances go through chemical changes to form a new substance. Now, there's some things that can help you determine if a chemical reaction is taking place or not, because we have signs or indicators that we can look for. So one is going to be a formation of a gas, a formation of a solid. We also call that a precipitate. And that there's a release of energy. So that could be a temperature change that may occur. So therefore, these signs or indicators are very similar to the signs that we look for chemical changes, but slightly different when you're looking at the terminology there. Now, when you're looking at these chemical reactions, they're going to have chemical energy. And when you're looking at chemical energy, this is going to be stored in bonds of atoms. So therefore, energy changes forms, but overall amount remains the same. So therefore, this is going to follow the law of conservation of energy. Okay, so it may change from one form to another, but the overall amount is going to remain the same. Now, when we are looking at these chemical reactions, there's two reactions that are going to be dealing with temperature changes. So we're going to look at an endothermic reaction. And when you're looking at endothermic reaction, more energy is needed to break the bonds of the reactants. So therefore, some examples of this are going to be photosynthesis, okay, so it has to pull in the energy from the sun, okay, that's the driving force when you're looking at the photosynthesis equation is over the yield sign. There's it says the word light because more energy, that light, is needed to break the bonds of those reactants there. Melting ice, ice packs. Now when I talk about those ice packs, I mean those disposable ones where you have to crack these little disc that's inside to cause the reaction to occur. that's how you're going to get that ice pack to become cold, is because you have that chemical reaction that is pulling that outside energy in. Now, the other is an exothermic reaction. And this is where energy is released to the surroundings as heat. Alright, so when you're looking at examples of this, you're going to have all combustion reactions, and heat packs. Okay, so endo means that you're bringing energy into it. Exo means that you're going to get it out. You're going to release it out there. So therefore, when you're looking at combustion reactions, you're looking at when you have a fuel plus oxygen giving carbon dioxide or water. That's a combustion reaction. So therefore, they are going to be releasing your energy in the form of heat. All right, that's why your car gets warm. It's because of that combustion reaction that's occurring there within the engine itself. So therefore, when you're looking at these two type of reactions and what's happening to the energy, okay, does it need more energy or is it releasing the energy? You have endothermic reactions and you have exothermic reactions. Endo means bringing it in. Exo means to release it out. Now, when you're looking at chemical reactions, we use chemical equations to show what was reacting in the reaction and then what was being produced in the end of that reaction. So therefore, we use chemical equations to show that. So it uses symbols to represent the reaction and show the relationship between reactants and products. Alright, so when you're looking at these chemical equations, we're going to look at parts of the equation. So if I had an example of CH4 plus 2O2 yielding CO2 plus 2H2O. Alright, and I wanted to know what my two parts were. Okay, I talk about these reactants and products. Well, what side's my reactants and what side's my products? To the left of your yield sign are your reactants. To the right of your yield sign are your products. Okay, your reactants react with one another to produce products. So this arrow here is yields, produces, gives, okay, depending on what language they wanted to use, that's what the arrow is, okay, it's the sign or produces sign or gives. So this would be CH4, so methane plus oxygen yields carbon dioxide and water, or methane plus oxygen produces carbon dioxide and water. So when you're speaking it, that's what the arrow is going to mean. These are the words that you might see possible for them to say what is being produced in the end. Now we're going to look at parts of a balanced equation to know all the different items that make up a balanced equation. Alright, so this is similar to the one that you just saw when we looked at reactants versus products, but different because now we have states of matter associated with this also. So when you are looking at this equation here, alright, you have these numbers in front. You have this number 2, that number 2, and that number 2. We call these coefficients. And we're going to work on being able to create coefficients of how you are going to be able to know what to put where. We still have our small numbers, so we have our small 2 there and our small 2 there. Those are still called our subscripts. We have our arrow, which is our yield, produces, gives. Now, on here, there's also states of matter. So when we're looking at our first state of matter here, this means that it's a solid. If we look at this state of matter here, this means that it's a liquid. Now, one that you may have not or probably have not seen before is this, for aqueous. And aqueous just means that it dissolves in water. Okay, so if you see that AQ, that means that it's aqueous, means that it can dissolve in water. And then our last state of matter here is a gas. Alright, so you probably recognize very quickly and easy solid, liquid, and gases. Because you have seen those states of matter before. What has been different is the term aqueous, where it means dissolves in water. Alright, so you have to be able to know and recognize what these different items are. Now, if they ask you what Na is, they may ask you what element it represents. So you would say sodium, or sometimes they'll say, what is this? It's just a chemical symbol. Alright, so it's just a chemical symbol when you're looking at this. When you're looking at NaOH, it may have you say what it is, where it's sodium hydroxide, or it just might say that it's a compound. Alright, so depending on what they ask for, will depend on what you have to describe. But these are the different parts of the chemical equations that you need to be able to know and be able to recognize, because you're going to have to label different parts of the equations over and over again, so you need to know what the parts are.